All right, so I think I'm recording. Let's take a look at solving these two equations. They are not quadratic equations, but they are what we call quadratic in form. If we look here at the middle term, this degree is 2, and the degree of the first term is 4, and then 2 is half of 4. If we look here, we have this x plus 4 over x minus 1 being raised to the first power, and this x plus 4 over x minus 1 being raised to the second power. 1 is half of 2. So these are both what they call quadratic in form, and we can solve these by a technique that's called a u substitution. So I'm going to look to this middle term, x squared, and I'm going to let x squared equal u. That means that if I square each side of these, then I'm going to let x to the fourth be u squared. So I'm going to rewrite this equation as 5, and instead of writing x to the fourth, I'm replacing x to the fourth with u squared. And then 26, I'm going to replace x squared with u. And so now I have an equation that I can solve either by completing the square, by quadratic formula, and I think even by factoring. And that's what I'm going to try right now, is to see if I can't factor this. Since the leading coefficient is different than 1, I'm going to use our x method. So I place an x above the middle term there, and positive 5u squared times a negative 24, is that not negative 120 u squared? And so now I need to come up with two numbers when multiplied together give me the negative 120, but add together to give me 26. So I'm going to want the larger of these two numbers to be positive. Yeah. All right. So if we try something like, 12 and negative 10, that multiplies together to give me the negative 120, but doesn't add up to give me 26. It only adds up to give me 2. So what if I try 24 times negative 5? Well, that adds up to 21, so I'm closer, but it doesn't add up. No, it adds up to 19. It doesn't add up to 26. Huh. So let's see. I'm going to break down 120 into a product of prime numbers so that I can see this a little bit better then. I've got that this 120 is equal to 2 cubed, okay, times 3 times 5. Now, if I try, what about 4? What about 30 and 4? Yeah, okay. So if I look at this as 2 squared, and I look at this as 2 times 3 times 5, I've got 4 times 30. Yeah, this is going to work. Okay, so let's make the 30 positive and the 4 negative. So if I try, and this is why they do call it trial and error, because you do have to play around with the numbers in order to find the right pair that you need. And like I say, we needed two numbers that multiplied together to give us the negative 120, but add together to give us 26. So I have found it in 30u times a negative 4u. All right. Now I'm going to put this information in the form of a table so I can factor this completely. So along one diagonal of my table, I use from the original equation the first term and the last term. And along the other diagonal, I use the two values that I found in my x. All right, so I can see that a -4 is common to both of these. And I can see that a 6 is common here, and +6 times a -4 is -24. I can see here that a 5u is common vertically to both of those, and across here that just a u is common. So 1u times 5u is 5u squared. -4 times 1u is -4u. And 6 times 5u is 30u. And we already said that +6 times a -4 was -24. So that allows me to rewrite this trinomial into u plus 6 and 5u minus 4. So this becomes pretty easy to see what the solutions are to this quadratic, really by inspection. So we can see that a u equals -6 will give us a product of 0. And we can see that if u were, let's add 4 and divide by 5. But now remember, we're not solving for u, our final answer has to be a solution set for x. So we replace u with x squared. And x squared is never going to equal -6, not within the set of real numbers. So this has no real solution. It does have what we refer to as complex solution with using the imaginary unit I, but we're going to look at that at a later skill packet. So over here, x squared is equal to 4/5, which means that we can extract the square root from here. Now we're not allowed to have that 5, the square root of 5 in the denominator, so we're going to multiply this by the number 1, but we're going to write 1 as 5/5. So that's going to give us a solution. Well, I can simplify the square root of 4. The square root of 4 is 2, but I can't simplify this square root of 5, and the square root of 25 is 5. So here's my solution set for number 4. All right. Now, I think I have enough room for number 5, but I'm going to shrink this up just a little bit just in case, or at least this part. All right. So here, my u substitution is a little more complicated because I'm going to let this middle term here, this ratio, x plus 1 over x minus 1, something that looks pretty complicated here, I'm going to replace that with u. And if I square both sides of this equation, if I take this fraction and square it, then I have to square the other side. So this thing that looked pretty ugly, now through a u substitution can be written as 4 times u squared plus 19 times u minus 5 is equal to 0. So let's go ahead and try to factor this by using our x method. Our middle term is 19u, and our first term times our last term is -20u squared. So two numbers that multiply together to give us this top value, but add together to give us this bottom, are 20u and -1u. I think those do the trick. So now let's, in the form of a table, help us factor this trinomial. This is just an organized way to apply the distributive property. The first term is 4u squared. The last term is -5, and we put that along one diagonal. And now along the other diagonal, the two values that we found from our x method. So when I look across here, I see that what's common is a -1. What's common here is 5. What's common to both of these is a 4u. And what's common vertically here to both of these is just 1u. So let's check. 4u times 1u is 4u squared. 4u times 5 is 20u. -1 times 1u is -1u, and -1 times +1 is -5. So this trinomial, we can factor it to 4u minus 1 times u plus 5. And that equals 0. All right, so let's try to give ourselves a little bit more room here, or to give me more room. I guess you're just watching. All right, so by inspection, I can see that u, if I add 1 and divide by 4, if u is equal to 1/4, that's a solution to this equation. Or if u is equal to -5, that's a solution to this equation. But originally, my variable is x, and that's what I need to solve for, is for x. So I'm going to come back up and replace this u with this fraction, x plus 1 over x minus 1. And I'm going to set that equal to 1/4. Now, that's a proportion, the claim that two ratios are equal to each other. So I'm going to solve that by cross-multiplying. And the same with this other equation. I'm going to write -5 as -5 over 1, and I can solve it by cross-multiplying. But I'm going to make a comment somewhere, and I'll just put it up here, that x could not be a +1, because 1 minus 1 would give me a 0 in the denominator. So whatever solution set I get for x, if it's x equals 1, I'm going to call it extraneous and throw it out. So let's draw little guidelines here for our cross multiplication. We're crossing over that equal sign. That's why it's called cross multiplying. All right, so along this diagonal, I just have x minus 1. And along the other diagonal, I have 4 times the quantity x plus 1. And maybe I'm not going to have enough room, huh? Nah, we can do it. All right. So if I apply the distributive property on the right-hand side, I get 4x plus 4. So if I subtract 1x from each side, and if I subtract 4 from each side, I get the x is -5/3. All right. Make sure I didn't make a mistake there. Let's see, I took away 1 from there. Then 4 minus 1 was 3. -1 minus 4 is -5. Yeah. All right, so over here, if I cross multiply, I get my x plus 1 is equal to -5 times x minus 1. I have x plus 1. If I use the distributive property, -5x plus 5. If I add 5x to each side, and if I subtract 1 from each side, and if I divide by 6, since both of these are even numbers, that would reduce to 2/3. So here's my solution set for number 5. And I know that neither one of these values caused division by 0, so I'm pretty confident that that would be correct unless I've made an arithmetic error. The technique was good. I don't know if I was good at applying the technique because sometimes I make silly arithmetic errors. But you can tell me whether that's the case or not. Ask any questions as needed. Let me know if you disagree with this and if I have to edit this video for other people. Hope that helps, and I'll talk to you later. Bye.